We're now going to be discussing factoring, and the first type of factoring is called common factoring. We're going to do some warm-ups first. Okay, so warm-up number one. This is a flashback to grade school. I want you to find the greatest common factor. So the greatest common factor, so I want the greatest common factor of 10 and 15. That's going to be the biggest number that goes into both of them. And there's a couple ways of doing it. One way is the good old-fashioned guess. You could be like, okay, there's 2 go into both of them. So 10 divided by 2, yeah, that's a pretty number. 15 divided by 2, not a pretty number, so 2 doesn't go into both of them. 3, 10 divided by 3, nope, that's ugly. 10 divided by 4, no, nope, that's ugly. 10 divided by 5, oh, that's pretty. 15 divided by 5, also pretty, okay. So 3 would go into both of them. So for example, the greatest common factor of this would be 3. So the answer is 3. The answer is 3. But another way of doing it, a more mathy way of doing it, is to break it up into prime factors. So 10 is the same thing as 5 times 2. 15 is the same as 5 times 3. Oop, not 3. 3 is not common. I made a mistake there. 5 is common. 10 divided by 5 is 2. 15 divided by 5 is 3. Why did I recognize that? Because when I made the factor tree, this is in common. So that's the greatest common factor. If there's 2 numbers in common, then you multiply them. So for example, what's the greatest common factor of 21 and 35? So that breaks up into 7 and 3. This one breaks up into 5 times 7. And we see that the 7 is common. So 7 is the greatest common factor. Or again, as I said, you could just divide things until you get the greatest common factor. Okay. Let's try 8 and 12. So the greatest common factor here is 8 is 4 times 2. That's going to be 6 times 2. 4 is 2 times 2, and 6 is 3 times 2. And there's 2 2's common on both sides. You only pick the bottom of the trees. And so 2 is a common factor, but it's not the greatest common factor. To find the greatest common factor, we have to actually multiply all the factors, and then that would be 2 times 2, which is in fact 4. So 4 is the greatest common factor of 8 and 12. We had 7 and 11. Not very exciting. 7 is 7 and 1. 11 is 11 and 1. 1 is kind of a common factor, but it's not really a good common factor. In math, we'll often call this a trivial answer. So it's true, but useless. So 1 is a common factor. 1 is a common factor of everything. Not too exciting. So really, we would say 7 and 11 have no common factors. Let's say we have 3 numbers, 10, 18, and 20. So it was going to be 10 is 5 and 2, 18 is 9 and 2, 20 is 10 and 2. Both of those are prime, so we're not making those any smaller. 9 is 3 and 3. 10 is 5 and 2. So we need something that's common to all 3 of them. So if we look, 5 is there, but there's no 5 there, so 5 is not common. 2, 2, and 2. Okay, there is a 2 that's common. And that's going to be it. There's 3 there, but there's no 3's there. And that's it. We have a 2, but we've already used up that 2. So in this case, the greatest common factor is 2. One more. Let's say we have x to the q3 and x to the 5. So x to the 3 breaks up into x times x times x, and x to the 5 breaks up into x times x times x times x times x. So it breaks up into 5x's times each other. So what's common? This x is common, this x is common, this x is common, and that's it. So what's common is 3x's, so the greatest common factor of x cubed and x to the 5 is actually x cubed. That's greatest common factors.